So now hydronium ion and hydroxide ion react together to form water molecules. What about sodium ions and chloride ions? They join together to make ionic compound. This ionic compound is a salt. But they never involve in the reaction between hydronium and hydroxide ions. So we are calling them watching ions on the sidelines. They are just watching. They never involve in the reaction between hydronium and hydroxide ion. So if equal concentration and equal volume of a strong acid and strong base are mixed, all of the hydronium ions and hydroxide ions will react together to form water. So the resulting solution is a neutral solution. Just check this with me. Now, if we cancel the spectator ions or the watching ions, sodium and chloride ion, you will find the equation of neutralization reaction can be written like this. Hydronium ion react with hydroxide ion to form water. Here, the acid cancel the base. They cancel each other, react with each other to form neutral compound, water. So we call this neutralization reaction. So when an acid reacts with a base, hydronium ions react with hydroxide ions to form water. The other ions, the positive part that comes from the base and the negative part that comes from the acid, they will form an ionic compound. This ionic compound called salt. If the salt is soluble in water, like sodium chloride salt, the ions will stay separated in the solution. Let me ask you a question. If a strong acid reacts with a weak base, the resulting solution will be also neutral solution? Or if a strong base reacts with weak acid, the solution will be neutral? The answer will be no. Why? We will know now why. Just follow me. The pH of the final solution depends on the amount of acid and base that are combined and the strength of the acid and base. So the strength of acid and base is very important in neutralization reaction. Neutralization reaction takes place between a strong acid and a strong base, HCl and NaOH, or H2SO4. This is another strong acid, or HNO3, nitric acid, a strong acid. So strong acids, when they react with strong bases, they will form water and salt, neutralization reaction. But if one strong and one weak, no, this is different. If a strong acid reacts with an equal amount of weak base, what do you think the resulting solution will be? It will be acidic. Why? Now a strong acid ionizes completely and form hydronium ions. So there is a lot of hydronium ions in the solution. But weak base do not ionize completely. So there are just a few hydroxide ions in the solution. Hydronium ions more than hydroxide ions. So the hydroxide ions will react with some of hydronium ion, and there are extra hydronium ions in the solution. Mean the solution will be acidic. The opposite when a weak acid reacts with an equal amount of a strong base of same concentration. So weak acid and strong base means a little hydronium ion in solution, because weak acids do not ionize completely. Few of hydronium ion and a lot of hydroxide ion, because this is a strong base. So this few hydronium ion will react with some of hydroxide ion, and there are extra hydroxide ions. These extra hydroxide ions will make the resulting solution basic. So again, neutralization reaction takes place between strong acid and strong base. The all hydronium ion will react with all hydroxide ions to form water. But if there is a strong acid and weak base, the solution will be acidic. If there is a weak acid and a strong base, the solution will be basic. What are salts? We keep saying salt, salt. When you hear the word salt, you properly think about white crystals that you sprinkle on food. The salt, the white salt that we use. But no, to a chemist, because we are chemists, scientists, a salt can be almost any combination of cations and anions. You know, cation is the positive ion, anion is the negative ion. So any combination between cations and anions, except hydroxides and oxides, which are bases. So hydroxide ions and oxide ions are bases. But any other combination between cation and anion, we call this a salt. Salts have many uses. Check with me in your book, please. You will find the uses of salt. Common table salt. We use this salt as a season and for food preserving. Baking soda is another salt, sodium hydrogen carbonate. We find it in kitchen. Your mother can use it in baking cake and so on. The chalk that we use it in our classroom is one form of salt, calcium carbonate. Walls in your house are made of gypsum, which is calcium sulfate, photographic film that contains light sensitive salt, silver bromide and silver iodide. So salts have many uses. Also, they are important inside our body. If you remember in the first semester, we said there are very important ions should be in your diet, like potassium, sodium, calcium, magnesium, iron, phosphorus, and iodine. You cannot ingest them as elemental form. We cannot digest potassium element or sodium element. So how can we digest these metals or ingest them? We ingest them through food in form of minerals. Minerals contain salts of elements that are needed for our body. Like what? Sodium chloride is a salt. Calcium ions, we receive them as a salt of calcium chloride, for example, or calcium carbonate. They are calcium ions needed for strong bones and teeth. Also, nerves and muscles need calcium ions to work. Potassium ions and sodium ions, they are needed for nerve impulses to work in a proper way. Phosphorus is a very important. It is ingested inside our body as phosphate ions. It is very important for transportation of energy and reproduction of the genetic code. So this is why salts are important also in our body.